Uh, Thank y'all for being here. I know Keith is next door right now giving a talk on how to get into application security. So today I'm going to talk to you about something you can do once you're in web application security, or application security, specifically web application security, which is seemingly most application security these days because everything now has a web interface, right? So today I'm going to talk a little about Selenium, which is an awesome tool. It's not a new tool. It's not a tool that I developed. It's a tool that I've found very useful in performing web application security engagements. And so I'm going to share with you some of the things I've found and some of the tricks that I've found to make it useful for web application security testing. This talk is it's going to include live demos, hopefully, recorded demos as a fallback. All the code that you're going to see is on my GitHub, the link at the bottom of the screen. The slides will go up there afterwards as well. So feel free to grab any of those examples. And everything that I do here is designed to be reproducible with a minimum of effort, just so that you can get up and running with Selenium just like right away. I want this to be something that you can take away and immediately use. So let's go. Selenium, the dark side of the moon. And this is frozen. All right, so who am I? I'm going to follow a kind of a who, what, when, where, how, why, and then why not of Selenium. So the structure of this talk is going to be me, what is Selenium? How does Selenium fit into the larger context of web application testing and browser automation in general? And then I'll get into the nitty gritty of using Selenium offensively, which is going to be the bulk of this talk. Finally, I'll get into the pitfalls of Selenium, how you can run into trouble with it, and then when not to use Selenium. So who am I? I'm Adam Reiser. I'm a security researcher at Cisco. I do web application security and I do product security assessments, which includes web application security and penetration testing. And in both of these roles, I've found that custom web application attacks are very, very important, either because of a product's actual production web interface or internal tools that have been developed by the dev team, often as part of a continuous integration environment, and developing custom web application attacks is very helpful in both scenarios. So, okay, what exactly is Selenium? So it's a set of tools, a set of open source tools, I should add, it's Apache licensed, to programmatically control a browser. This refers to a stock unmodified browser, so just actual Firefox, Chrome, Edge, IE, pretty much any modern browser supports it through a standard called WebDriver, which I'll explain in a bit. I should qualify, it's not precisely a standard, it's on its way. As I mentioned, it's widely used in web application testing, not associated so much with web application security testing, but I think it should be because it's very useful for it. It can be used for web scraping, obviously. The key difference that distinguishes Selenium from many other tools to perform testing is that it simulates user actions. That is, it automates user actions. It's what I kind of jokingly call layer 8 automation. And the selling point of Selenium, apart from being one of the oldest, probably the oldest and most mature browser automation framework, is its compatibility across browsers and languages. It attempts to be as vendor neutral as possible. As I mentioned, it's compatible with pretty much all modern browsers. It's Safari as well, and you can use it with mobile support. It's not supported natively. There's a couple of projects. One of them is called Appium. The other one escapes my mind at the moment, but there are ways to run it with mobile browsers, which everyone asks about these days. That's not going to be the focus of this talk, again, because this is based on attacking web applications and not so much on kind of like UA acceptability testing. Compatible across languages, the Selenium libraries are available in pretty much any language you're likely to use. Well, Haskell support isn't quite there yet. But if you want to, say, automate Firefox in Python, very common. Those are the examples, the majority of the examples and the demos that I'll be giving in this talk, because it gets you up and running really quick. But if you want to automate uh, Safari in Ruby, or you could even automate Internet Explorer and PHP if you're perverse that way. And the best part is that the basic techniques in the WebDriver interface really don't care. Only the high-level code will change. So the Selenium ecosystem, as I mentioned, there's many browser automation projects. These usually are based on, you may have heard of, say, like PhantomJS or some of the derivatives that are used at a higher level to run it. These are usually based on or support WebDriver. For example, PhantomJS has its own WebDriver called Ghost Driver. And by the way, if anything in the demos that I'll be doing is illegible, if the font's too small, just shout out and I'll zoom in. Uh, the big development now that makes Selenium seemingly uh, destined for dominance in the browser automation uh, space is the increasing native support, native headless support in major browsers. This was a development, I believe, led by Google through headless Chrome, which I think was just made public this year, followed by Firefox. And this has led to headless Selenium becoming really kind of the framework of choice for doing browser automation for pretty much any purpose. Of course, these have malicious purposes, not just offensive testing, but it's used for actual malicious reasons by spammers and other unsavory uses, which I won't be covering because you guys are all white hats, right? Okay, so to begin with, to convince you that Selenium is cool and useful and can actually do something with a modern web application outside of the lab, I'm going to start by testing a client-side attack uh, through a modern web application. And what's more modern and cutting edge than Gmail, right? So we're going to simulate a user on an engagement who unwisely logs into Gmail and clicks on a link that we send him. I've used this kind of technique in doing demos. Management loves this stuff, by the way. Just a little tip. They love seeing browser automation because often they're not like familiar with what it can really do. So we're going to fire up our Gmail demo, and hopefully it'll work. If not, fall back. So let's step away and watch the magic hopefully happen. It'll take a couple seconds here. There's the link. Let's have our victim open the link. Oh, no. Okay. All right. So Bob from accounting or whoever clicked on our malicious link and he got malwared. Uh, all right. So let's have a look at what the hell was Bob thinking. Uh, the good news is that Bob is actually quite simple. And again, if any of this is illegible, just yell it out. I can see the red doesn't show up too well. Uh, this is more complicated than it needs to be because I'm demonstrating action chains there. So let me, which I'll get to in a minute. Let me pull up Gmail no actions. The good news about this is that it's really quite simple to do this. As you can imagine, the Gmail login process, I'm sure all of you have looked at like Google's HTML at one point or another, and you know, of course, it's enormously complex and optimized, and you don't ever want to have to parse it. And the good news is you don't ever have to if you're using Selenium. You just have to figure out how a user would interact with the page, which is as simple as figuring out what buttons to click on, specifically some way to identify the buttons that you're going to click on. So there's a few things going on here. What I want you to take away from this demo is that it really boils down to about 5 lines of core code here. Our WebDriver, we're finding an element, we're sending a username to it, we're waiting. Don't worry about WebDriver wait if you haven't seen it before. And then we send a password to it. And that demo doesn't have the final couple of lines. we're actually the other thing I want to emphasize here is that we're not relying on any of Google's page structure. We're literally looking for just a span, open me, probably going to be pretty reliable. That's probably not going to change. Again, if you've looked at the actual like Google code, they have just like all kinds of short, impossible to understand names in all of their interfaces. So this should be probably relatively resilient, although there's always the risk of getting the CAPTCHA if we make too many automated queries, which I'll discuss in a minute. Okay, so now I've hopefully convinced you that Selenium can actually do things that are useful against a real application. So now I'm going to step back a minute and talk about how to use Selenium, specifically the components and toolkit that you'll need to get started with applying Selenium to the dark side, the dark arts of Selenium. So you'll need your browser to automate, obviously, the stock unmodified browser. You can use pretty much whatever you want. Again, I use Firefox and Chrome for some examples. You'll need the corresponding WebDriver. WebDriver is a W3C candidate recommendation at the moment. It's on its way to becoming a standard if it isn't already. What WebDriver is it defines an interface. So it's great because that makes it language neutral. It defines an interface, and then anyone can write a library for it. And any vendor can write a WebDriver to work with that library. And all the major vendors have done so. So, for example, Chrome is available. I believe it's either Google or a Google project who makes Chrome. It might be Chromium who makes the Chrome WebDriver, but Mozilla makes the Firefox WebDriver, Gecko driver. I believe Apple makes the Safari driver. And yeah, Microsoft obviously makes Edge and IE drivers, and there's mobile drivers through Selenium Remote. So you'll need the browser that you're going to automate. You're going to need the corresponding WebDriver, which is usually just a binary that you just end up dropping in your path, and the libraries will find it. That could vary by implementation. You'll need the Selenium libraries. In Python, that's as simple as pip install Selenium. What could be better? You'll need a DOM inspector. These are in all major browsers, of course. But that's obviously important for actually understanding the page that you're going to crawl. And finally, this is not necessary, but this actually is a critical part of the toolkit, is an application proxy, because like Burp Suite, but you can use any, obviously, a MIDM proxy. What we'll be doing later in the demo is hooking up Selenium through an intercepting proxy so that all the traffic that passes through it will all the traffic that Selenium generates will pass through the proxy. And that has a number of advantages. Finally, we'll need our lab environment because we're obviously not going to be doing our development on. We're not going to be troubleshooting our scripts and hitting real services again and again because we'll probably get banned. So I'll do a quick overview of Docker. You guys probably are all familiar with Docker and containerization in general. But I'm going to just do a quick overview of how I set up this particular lab to run a complex web application and how it really is just ridiculously simple these days with Docker Compose, even for applications that require multiple containers for like a database backend. So this setup, I just used a Kali VM because I didn't need stealth. As we learned yesterday, Kali's not stealthy, but it's not required for this case. The easiest way to get it running just in a temporary lab I've found is just grab the .deb files and just depackage them. Like you don't need to mess around with actually getting the repositories all set up if it's just a temporary testing thing. It always seems to change. Like it's now Docker Community Edition. It didn't used to be that way. And then you need to get the Docker Compose binary and just drop it somewhere in your path. Okay, so we assume we've got a Docker setup now. And the next steps, we're going to use Mediawiki for our testing application. Is something that's relatively complex and that one might rightly assume would be a pain to set up. Except that now with Docker, that assumption is no longer right. So Mediawiki has kindly provided a Docker Compose file. And if you're not familiar with Compose, it provides just a simple way of managing a multi-container environment. And their Compose file I've modified slightly for this demo. It uses the official Mediawiki and Maria database images. And if you download the my Git, you can see the it's Docker Compose YAML. And so once you have it, it's as simple as doing Docker Compose up, and you'll have an unconfigured Mediawiki instance on your localhost port 8000. And you set up the wiki, you just step through a bunch of questions, basically. They should all be pretty obvious. You just pick the username and password. The default that I picked out are just in the YAML file. The only thing that's vaguely tricky is database host. Or Docker Compose. If you're not super familiar with Docker, that's defined by the link. I actually tab over to the Compose file so that you guys can see it. So this is basically almost the official Mediawiki Docker Compose image. Only a couple changes to make it run on port 8000 instead of 8080, which conflicted with the burp default. It was easier to change this. Easier to change Mediawiki than to have to change burp every time I started it. So the thing to note here is the links database in the definition of the Mediawiki container here, just to make sure that it's connected with there. And that means that the database will resolve as a host name to the database backend for the wiki, and the password for the that you'll enter. So yeah, I don't want to spend too long going through Mediawiki and Docker, but basically at the end of that process, you'll end up with a local settings.php file, which you'll then need to copy to the Mediawiki directory. Control C to terminate the Docker Compose up gracefully. That will populate your MariaDB database directory. Then you just remove the comment from the compose file and do Docker Compose up again. And you'll be back at, or you rather you take away the comment so that it actually will load the wiki configuration PHP, and you'll have a live empty Mediawiki that we can now play with. So how to actually start using it, sketching a Selenium script. It used to be Selenium had a feature, technically it still does, called Selenium IDE, which was another thing that was a somewhat controversial feature because it was one of those program without programming type things, that crop up periodically, like program in natural language fads. Well, this was a program without programming at all because it was kind of useful, kind of cool for occasional purposes, but it was controversial because the code it produced was quite bad, and sometimes that code would end up making its way into actual real tests, and other people who knew the language would stumble across it and be shocked. So that could explain in part why development for Selenium IDE has fallen off. What it is it's basically a record button in your browser that you hit the button, you step through some series of actions, it generates a test case or test suite, whatever it was called, and then you can play it back. And in theory, that's great. It was kind of cool when it worked, but it was clunky, clanky, and the code it produced, as I mentioned, was quite horrendous in a lot of cases, and it would usually require manual fix-up. So it may be a good thing that development has kind of fallen off of that. It's not compatible at all with current Firefox because of the switch to web extensions you may be familiar with. It hasn't been ported to that yet. There are a couple of efforts to it, but they're not quite there yet. There was another valiant effort called Selenium Builder to reproduce the same thing. So I tried that out on a test VM. After I installed it, it opened up a new page, and I found that the about info page for it that it opened up, like NoScript does, you may be familiar with that, and the domain was parked. So that was not a good sign, and I decided it was time to give up on trying to include a way of getting into Selenium through the GUI. So I came up with this framework for sketching a Selenium script, which I have here. This is pretty much the minimal Selenium script that you can have. I'll just open a web browser window to localhost port 8000, which is where our Mediawiki lab is set up, and it'll just wait. I've added a couple things here. You may be familiar with them. This is obviously Python. We're going to be doing this in the Python interactive shell. And the key here is tab complete. This makes it super fun and cool to navigate Selenium objects, which are complicated and have strange names. So this is onesmallstep.py if you're looking at the GitHub. So what we're going to do is Python I, one small step, I, to say that when you're done with the script, leave it in interactive mode. We'll run it and step back. Here we are in the wiki. Notice a couple of things here. We have a little robot icon indicating obviously that our browser session is under remote control. And we have the Python prompt here. Now we can click away from there. And if you look at the onesmallstep.py, I've called the WebDriver object WD, specified the Firefox binary location just because the default was ESR and I didn't want to mess with it and didn't want to use ESR. So let's look at our WD object. Let's now do tab completion. Unfortunately, there's not a good way to illustrate this. I'm just hitting tab quickly twice to see all the things in WD, all the members of the WD object. You can see a bunch of potentially interesting things. I want to call your attention to something like wd.getCookies. So we could do that, obviously. And what a surprise, there aren't actually any cookies because we haven't logged in or done anything. While we're in this session, though, we can do everything that we could do on the page. So let's manually construct some actions. So I mentioned that one of our tools was the DOM inspector. So let's go to the Firefox developer tools and take a look at the DOM, and let's actually construct a script. So we might want to start by logging in. So let's mouse over to login, click on it. And again, if anything is illegible, just yell it out. Don't raise your hand because I probably won't see you because I get distracted easily. Just yell. So we can see that our login page obviously has the text login. That's a link, so that is one way we could try to select it. It also has the ID PT login. So there's a number of different ways that we could refer to it. ID is probably the best way because it's going to be unique on the page. So we'll do WD dot. You can see the pattern. These all begin with find. So let's do WD.find, tab complete. Again, you have to hit tab twice usually. Find element, double tab again. Find element by ID. Let's do PT login. We can see that returns a Firefox web element object. And that's great because that's something that we can now interact with in the Selenium script, which we could add to our actual script, or we could continue to interact with it here, or we could start to interact with it. Just make a new login object so that we can see the members of it. And so login dot has a bunch of different things. Something obvious we could do. Let's click on the login link to do that, and notice what happened over here. Now we're in the login screen. And so you can see that you could continue to do this process. There's more. If we had done login dot send keys, if it was a text field instead, like that is, we could send our username and password to it, and then click the login button or just hit enter, which is what we're going to do. In the completed script version of this, which is wiki login wikilogin.py. No, sorry. Okay, so really quite simple. Just basically 4 or 5 actions. We get, after getting our local host, we're going to maximize the window. Again, it's a method of the WebDriver element object. We click on the PT login, and we've used the same method with the DOM inspector to find the element ID, WP name. We read the username and password from this file, which I didn't include in the repository, just kind of out of well, how many times have we seen credentials in a repository? These are just test credentials. Who cares? But it just rubs me the wrong way to see credentials. Yeah, it's just Selenium 123 are the default credentials. So it totally doesn't matter. But just a pet peeve that is probably pretty common. So I'm using find element by ID and all of these. Obviously, as you saw, there's a number of different ways you can do that. If we go back to it, one other one that I want to illustrate is find element by link text. This is often very useful because link text pages will change. Like the way that a page is structured is going to change. That's a given. Page interfaces do change as well. You can have a script that will try to find an element by both something like ID and what it looks like to the user, in this case, link text. And that can be helpful in trying to make robust scripts. I say trying because you can never guarantee that it won't break, because sometimes entire sites will just become like, what is this? This is not even usable for a human user anymore. But I want to just illustrate quickly, find element by link text, just because that's something that is very useful. Now, the link text has to be complete, so it's got to be the actual full text of the node. If we do just log, it's not going to find it. There is another one by partial link text that actually could be more useful if we just find login. Well, and you'll notice that I screwed up here and I called it login when it's actually log space in. So what's going on now, which is going to be a segue for the next topic, is implicit wait. Right now it's waiting for 30 seconds that I've defined to find that element on the page. And once it times out, it's going to assume that the element's not there, and it's just going to fail out of that example. And I was hoping that I'd be able to there we go. I did manage to talk for long enough for that to actually happen. So let's do this properly. Find element by partial link text, log, and there it is. And so something you may be asking is, what if these things are not unique? Obviously, IDs are going to be unique. But something like link text, there's no guarantee and not a particular likelihood that it's going to be unique. So this is one of the pitfalls to kind of preview of Selenium that you need to watch out for, which is find element versus find elements. This comes up a lot. People ask me about this. Very similarly named functions or methods. Find elements by ID versus find element by ID. This will return a list. That will return an element. So just make sure you know which one you're using. And by the way, if there are multiple elements with a given characteristic that you've found, make sure you know that find element will go to the first one it finds. So if you just want the first one, you can always use find element. It just might not be the one you expect. Okay, so that is the basic skeleton of a Selenium script. So let's just go past the fallback demo. Okay, so our next topic is adding a proxy to Selenium. Suppose we encounter a page like this. It may be a little hard to read. Basically, an auto-submitting form in a page that maybe it was generated dynamically. Whatever reason, we don't really care. But we have something in a page. We don't want the page behavior to do what we don't want the browser to do what the page tells it to do, if that makes sense. Can we pause Selenium here? Can we tell it, hey, wait, no, don't actually do this? Well, not really properly, not reliably. There's not a good way to do this because Selenium, although it provides introspection, specifically that's what WebDriver does, it doesn't give you a real framework for hooking browser events. You could get fancy and use a tool like Frida here to get really crazy and browser specific. That's not necessary. Proxy to the rescue. We can actually stop this from happening, but not using Selenium directly. This is one application of a HTTP-aware proxy that I'm going to talk about. Proxies have many advantages. You should basically always use them whenever you're using Selenium for offensive testing. Logging, obviously, the main thing they're useful. One of the main things they can do, just show you all the transactions that you've done. As we also heard yesterday, Burp Suite is very good for just troubleshooting, even when you're not trying to attack something. Performing on-the-fly request and response transforms. You can modify a request or a response before it hits Selenium or the browser, according to regexes. Examples we'll be using are with Burp Suite, but again, you can use any of them. You can enforce a scope if you're on a pen test engagement. If you've ever done something like that, you all know that staying within scope is something people care about for some reason. So you can use Burp to restrict all your requests to a particular domain, even if the page is trying to send you somewhere else. You can also take advantage of just tools that are included with proxies like Burps, issue detection, or some of the extensions in the Burp app store, like Collaborator. And as I mentioned in the original case of a auto-submitting form, you can halt a transaction. Okay, so how do we actually add a proxy? We need to step back and talk about how Selenium works when it starts up those new browser sessions with the little robot icon. The thing to be aware of is that every run of Selenium creates a fresh profile, like a default from scratch profile with no customization by default. And this is necessary because since it's used in application testing, you want to make sure you have reproducible results. So you can't have your Selenium sessions getting clogged up with old profile data. So what we have to do is pre-configure before we actually launch the WebDriver. We have to pre-configure the new profile to use a proxy. And furthermore, we also have to ensure that the proxy certificate authority is installed if we want to actually do anything useful. Specifically, if we want to man-in-the-middle HTTPS connections, as I'm sure you've concluded. So the proxy and preference mechanics look something like this. This is a little snippet of a class that I created for the demo that I hope could actually be useful to someone in developing offensive tests. So basically, this is how you create, how you set the preferences for a WebDriver, or a new WebDriver browser session. This, unfortunately, is browser specific. I don't know well, of course, there isn't a way to do this in a browser neutral way because all browsers have different preferences. There isn't a standard API for things like proxy settings, as far as I know. And the most specific thing here, the most browser-specific thing, which is kind of a clunky hack, is the way to install the certificate authority, which is kind of embarrassing. But the way to do it is you copy the cert8.db file in Firefox from a browser profile that has been configured to trust the Burp certificate authority. And I'm sure you all know how to do this, but I'm just going to step through it just to make sure we're all on the same page. Let's just go to a browser session, make sure it's hooked up to, I'm using just a one-click proxy setting. Just figure it. Let me just go to HTTP burp. And yeah, we click on CA certificate, get the .dir file, preferences. I'm sure you all know how to do this. I don't know why I'm bothering with this. Where did they move it to today? There we go. And yeah, you import a certificate, make sure it's an authority and not a certificate, because the way that HTTPS proxies work, obviously, each website's going to have its own certificate. So you need to import a certificate authority. And the way the proxy works is it'll then generate an untrusted, by default, a certificate on the fly for every site that you go to. So we import the downloaded CA cert.dir, and I already installed it. And so that's basically how you install that certificate authority into Firefox in this case. And then you'll have your .mozilla Firefox profile, or whatever the random name it gives it. And then you'll have a cert8.db file, and that's where the actual trust information is stored. And so that's the file that the script needs a path to, and will then copy to each new Selenium profile that you set up. So that is the kind of like clunky part that I don't really like about this, but I haven't found a better way to do. The underlying code uses something called NSS. I think that is very complicated, and I got scared when I looked at it, so I decided this is a better way to do it. At least it was a way to. This is the way that I ended up doing it. You probably don't want to mess around with NSS. It's kind of horrifying. Anyway, once we do that, we'll be able to see all of our sessions in our proxy's history. So let me just show you how that works when we decide to proxy our Mediawiki connection. Oh, and one other thing to note in the proxy settings, get out of Mediawiki, is Selenium profile.py. By default, it'll Firefox will, and probably other browsers, will choose not to proxy localhost. And we need to make sure that they actually do proxy localhost. So let's Python I wiki login, or make sure that, wiki login, okay, it does not use the proxy. Wiki, this is wiki proxy. While that's running, we'll go over to our burp, although that'll soon be overlaid. Hey, stuff's happening. Okay, so everything that happened here, which unfortunately this one didn't wasn't one that logged us in, so it's not that interesting. But we can see every action that this browser takes is logged through burp. Most interestingly, of course, we see that our HTTPS interception is working properly as the browser loaded Mozilla's advertising stuff and what's that? The Google malware blocker or whatever. And you can also see what plugins I have installed. Okay, so super useful to be able to hook up a proxy to every Selenium instance. And we just have to leave burp open here. And every time we run this wiki proxy, or, oh, there it is, wiki proxy login, everything will automatically go through here. And of course, you could script the invocation of burp suite so that it starts up a new session every time. So now we've actually logged in. Now we can sniff the login traffic, and you can see the password and all that good stuff. So where do we have it? Special user login quest. And there we go. So there's the actual login. We can see that instead of just submitting a form like in the old days, now we have to deal with things like the anti-CSRF token and just other things that just would be a pain if we were trying to automate this with just like a series of curl requests, which is why you don't do that anymore, and is really why we need to simulate or emulate user actions to meaningfully interact with modern web pages. This is a relatively simple example of navigating into a web application, and they can get much more involved, and you wouldn't want to have to actually reproduce every transaction, as I'll show in a second. So a more complex example that I have run into, and what is going on there? There we go. What? Okay. So more interesting example is handling SSO. So this is something that I have seen where I was trying to develop an exploit for an application on an engagement, and part of that involved having to have a valid SSO response token, assigned a token from the identity provider that you can present to the service provider on the left, and that only works once. Once you've sent it there, the service provider's not going to want to see it again. So the use case for the proxy here, in this case, was to halt the transaction at the identity provider response token. We wanted to say, we get this token, and we don't want to do anything else with it. We want to just quit. We don't care about it anymore. We want to be able to write it to a file, send it to another script that's going to try to develop an exploit using this token as part of its configuration. So we needed to actually capture the token in a state where it hadn't been used. And this was stupid simple to do with burp. All we had to do was go to the intercept configuration, intercept a client request. It matches some Boolean conditions. That's a made-up URL to log in v2 SAML. Don't try to figure out what application this was. But it looked like this. And so every time that we would do this, we'd end up with the request just paused for interception in the probably know the burp intercept window. We just have intercept on, and options to intercept client requests was set here, and then it would just show up here. We could ignore it, and Selenium would time out, and we could go on our merry way. Okay, so now some pitfalls and gotchas of Selenium. So timing is a big one, dealing with timing issues. I see that it could be an issue for me as well. So I'll try to get through this. Defining what you want to actually happen is important. Basically, the way that Selenium will proceed with a series of steps is it waits for an element to appear. And actually, yeah, let me just summarize these and then get into that. So timing, XML, HTTP requests, anything asynchronous scripts can trip you up as well. Anything that visually looks like an element fading in or being ghosted can also be a problem. And composite actions, things that expect you to like mouse over a link before you click them. And these are all things that we have ways of dealing with. And finally, bot detectors, aka people trying to stop you from doing exactly what you're trying to do. And frames, which are kind of boring. So timing, we run into this. Suppose we're implementing a tool like HTTP Screenshot, which is an existing tool that will take like an Nmap scan result, and we'll just crawl every page to just get a screenshot of it and just see what's there. That means that it has to actually load each page. And what do we mean by load exactly? When we actually load a page, a number of things are obviously going on, some of which include scripts. And those scripts can be kind of time bombs that may change how the page actually looks. And what we mean by load might not be what the browser means by load, as I'll illustrate in a second. Ultimately, this is undecidable. It's the halting problem. You can't actually tell when the page has finished loading. There's no way to tell whether it will finish loading or what you want. So there's no way to do this universally, and I just hope to provide you with the tools to do it on a case-by-case basis. There's a quick example. Suppose our little Selenium tester user is searching for a job as a geologist, and he wants to just crawl this site, this job search site, and just get a snapshot of current geologist jobs every day or so. So he might say that, okay, the page is loaded when it looks like this. But the Selenium script might say it's loaded when it looks like this. I mean, more content is loaded, right? This is what you want, isn't it? Okay, so probably not. So let's talk about the tools that you'd use to deal with that kind of problem. Implicit waits are the default, the original, and still the most common way of handling elements in a page. It's just a method that you call once in your whole script. It's just a timeout in seconds that says, I want to wait for up to this many seconds to find any element that I refer to in a page, and just fail if you don't find it. So the way this works is it will the implicit wait method will say that we're going to pull the DOM until the desired element exists every I think half second. And as I mentioned, this is frequently not good enough. Something that can go wrong with this that you may see is this error. Element is not visible. And your reaction may be something like that. What's going on? I can see the element is visible. Why can't I interact with it? And this is often something that crops up when an element is ghosted or fades in. And at the moment that Selenium sees it, it's not actually interactable. If you clicked on it, nothing would happen. But you don't realize that because the timing window is so small. So the solution to this is some helper methods and libraries, WebDriver wait and expected conditions. And I realize this is pretty ugly syntax. The good news, though, is that you only really have to. It's really kind of a one-trick pony here. So you'll notice you're calling WebDriver wait with WD as an argument. It's not a method of WD. And then you wait until the expected condition element is clickable by ID. It's almost natural language, which makes it hideous. But you can probably see where it's going with this. It's waiting for an element to meet some condition in the expected conditions library. And then and only then, once the password element is clickable, will it send keys to the password element. And again, tab completion in these sample scripts that I have is super handy because you can just do ec dot tab to see all the conditions, and of course you can also just read the documentation. Who does that? Finally, one of the last topics before we run out of time is composite actions. Selenium actions versus user actions. These can differ in sometimes subtle ways. One example, which is probably pretty familiar, is on mouse down. Elements that will react when you press the mouse down. When you click on them, but before you release in that window, something on the page changes. Also on mouse over. Modifying the DOM can result in stale elements. I'll just do a quick example here of on mouse over from something that probably everyone's familiar with. I'll just reuse this Selenium session here. So let's just do a Google search for wiki. And it's searching Yahoo because it's horrible. We still have the connection. May have to skip this. Should load. It's just being, or was it? Oh, maybe I left intercept on. Yeah. All right. Okay. So probably all of you have seen this behavior, but the way that it works is you notice that I'll close the developer tools. Google seems to give you the lower left-hand corner. Actually, that's probably pretty illegible. The link is to Wikipedia. We click and hold on it. We can see that the link is now changed to google.ca. And the way that worked, which if we inspect it and inspect the element, we can actually see the little JavaScript snippet that rewrites the URL. So that's an example of how a page can change on the fly. And if you just told your Selenium script to click on it, I think in this case it actually will register the mouse down, but it won't register a mouse over. So in some examples that will, in some cases, some pages, clicking on a link without mousing over it will result in different behavior from clicking on a link, just using the click method. So listeners can react in different ways. And there's a way to build composite actions using what's called action chains in Selenium. It's another library, the long, difficult to remember name that basically, but it's really easy to use. You just import it, you pre-configure an action, and then you move to the element. That's the mouse over, and then you click it. And then every time you want to run that action, you perform it. You just do action.perform. There's different ways of using this. This is just one of the simplest. And when you do that, a lot of the times, or some of the time anyway, you'll go WTF, stale element reference exception. Well, all that happened was that the page changed in some way, and basically you just need to find the element again after mousing over it. And I have another demo that we may not have time for, but we'll see. Remind me to show you the on mouse over demo in a minute. Bot detectors, CAPTCHAs obviously are the main way that bots get detected. Silent alarm style detectors like BotGuard is something that Google uses. These can work by browser fingerprinting. These can trip up Selenium. They employ heuristics to detect how actual interactive user sessions differ from Selenium or otherwise scripted sessions. Main thing to remember here is that mobile clients may have different, and guess we are out of time. So I'm not going to talk about frames. I just want to briefly mention PhantomJS because people always ask me about this in relation to browser automation. It's just another approach. The thing to know about PhantomJS is that Selenium and WebDriver together drive a browser, whereas PhantomJS is a browser. It's faster and less resource intensive. It has some advantages and disadvantages. The main disadvantage is the maintainer stepped down last April, citing headless Chrome as a likely replacement. So probably the way to go is to use WebDriver for your future tests. This is just a quick example showing that Chrome and Firefox scripts are almost identical. Adapting from one browser to another is super easy. When don't use Selenium whenever you don't have to. I know that doesn't sound like a ringing endorsement after everything, but it's not an API replacement. Browser automation is very slow, resource intensive, and it's a last resort. It's often a resort that we do have to come to, but don't use Selenium unless you actually need to do web scraping. And here's some references for the reading. Contact info. Feel free to email me. That's my personal email. Everything out here is on my GitHub. That's pretty much it. Stay on the light side, but know how to use the dark side of the moon.